Hello everyone, welcome back to 17b. Today we're going to talk about the exactly distribution of the sample proportion. Uh, so first thing first, you need to know what's the sampling of the small population. If we have a big bag for the 6 blue balls and 4 red balls, for example, and the bag we take in the sample size of 4, so which is we're gonna take the size of 4, and then we increase about a proportion of the blue balls in the samples. So the proportion for the E. coli will be like 6/10 because will be around like 60% to take one um, sample of the blue ball. And we support the probability associated the possible value of sample proportion can be calculated by this can calculate by this formula. So we could record that one as a number of different ways to select the x objects from n objects. So I will do some examples like that. So first thing first, as I said, you had a blue ball, 6 blue balls and 4 red balls, and we taken random sample size of 4. What's the probability of there's one blue ball in the sample, which is we say one blue ball of the sample size. So consider we have a sample take one ball from the bag at a time without replacement. Okay, without replacement. So this is a without replacement. So the probability to take 4 balls out of these 10 balls can be red, 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 and blue. And next one will be probability of red, red, and because it's one blue ball, so it can be blue and red. And probability of red, blue, red, red. And the last one will be blue, red, red, red. And you plus all those together. So because without replacement, so first one, probability of red, 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 blue. So that equal to first one, which is the red one, so 4/10 multiplied by 3/9 multiplied by 2/8 and multiplied by, because it takes 3 balls out the 10, so which is 7 balls left. How many blue balls you have, which is 6/7. Yep. And then you plus all together, which is the next one will be probability of red, red, blue, red. So that equal to 4/10 multiplied by 6/9. Sorry, not 3/9, and multiplied by 6/8, and multiplied by 2/7. Yep. So plus, okay, so plus, and then you plus again. So probability of red, blue, red, red. That equal to so 4/10 multiplied by 6/9 multiplied by 3/8 multiplied by 2/7, and you plus again probability of blue, red, 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 red. So that will be 6/10 multiplied by 4/9 multiplied by 3/8 multiplied by 2/7. and that equal to 4 over 35. We keep going. So this is a methods one. So we can say method. And if I using another methods, which is we using the methods two. So we could do because you select the 4 balls from a 10. So there's the so we calculate these by from a CAS calculator. So that equal to 210 ways in total. Um, and then so we are choosing from those 4, and we have a 3 is a red ball, and which means we're choosing from 4 red balls to 3. There's a 4 ways of choosing 3 red balls from 4 red balls in total. Because in total you have 4 red balls, but you're choosing 3. That's the 4 ways to choose. And you have a 6 balls for the blue balls, and by you only choosing 1 for blue ball. And that's 6 ways of choosing 1 blue ball from 6 blue. Yeah. So in total, so will be 4 red balls choosing 3 multiplied by 6 blue balls choosing 1 and divided by in total 4 random variables. So this is 24 and this is 210, and that equal to 4 over 35. Oh, again. Yeah. So either way you could use. I don't really mind. Doesn't matter you choosing which way you want. So hopefully that makes sense. And now we're gonna using the statistic, which is calculate a sample such as the simple proportion of a special name we call sampling distribution. So here is a bag of 6 and 4 balls together, 10 balls and 6 blue balls, 4 red balls. The sampling distribution in the Puris table for the determine the probability that the proportion of the blue balls are sample of the size 4 is more than quarter. So which means more than quarter is not equal to quarter. So we can calculate the probability of the simple proportion greater than quarter. What does that equals? We can choose the probability. The simple proportion are equal to half plus the probability of the proportion are equal to 3 over 4, and the probability of proportion equal to 1. So that's it. So how we calculate these? But we could just using the exactly same ideas from your previous questions, and to add them all because equal to half. So if that equal to half, so we can say we're choosing the ball which is of the blue balls can be a size like more than, which is like we can choose 2 blue balls in the sample size of the 4. So which is like if they say a probability of the equal to half, means choose 2 blue balls, and the probability of the pay equal to 1. That means choose 4 blue balls. So does that make sense? Like if you like size of 4, right? You're choosing, if this is a quarter, it's a 1/4. That means you're only choosing 1 blue ball of the 4. But if it's half, that means you're choosing 2. And then 3/4, that means like you're choosing 3 blue balls out of 4. So that's how that works. And you're just using the same methods over here to calculate each of them, which is I did earlier. So which is, this is a probability of the half, and plus 80/20. That means this is a probability of the p equal to 3/4, and plus 15/210. That means the probability of 1. That equal to 37/42. So this is a whole populations. Is the sample size greater than a quarter. That's it. Now you have the question like the sample distribution of the periodic tables, and I will show you this table during the class. We can do this one like in the class. So but I want to show you guys the mean standard deviation, which is here. So how we do the standard deviation of the questions like that. So if I have this table which we calculate the mean standard deviation. So the standard deviation by mean, so which is we using the sum of the proportion of the sample distribution multiplied by probability of sample equal to the p. So which means if I select the 0 multiplied by 0.0081 and plus 0.25 multiplied by 0.0756 and blah 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 to 1 multiplied by 0.2401, and that approximately equal to 0.7. So that was your mean. And once you had that, and you could just doing by standard deviation, which is we're using the stand but not distribution, which is use the square root of e square minus e square. Yeah, so we're just substituting in, but now we calculate the e to the square first. So that means the square multiplied by 0.0081 plus 0.25 square multiplied by 0.0756, and keep continuing going to 1 square. So plus 1 square multiplied by 0.2401, and that equal to 0.5425. And the standard deviation of the sample will be equal to 0.5425 minus 0.7 squared, that equal to 0.2291. Approximately, yeah. So this is a formula you can use, and this is a formula you can use. Here is the formula I want you guys to remember. There is the simplest way to calculate, to put into the bound reference place. So we're using the same rules to calculate these questions. And this is a question we're gonna do in the class as well. So this is a total, the whole thing together, and in the 17b, which is we're gonna do step by steps. So basically, this is all you need to know from 17b. And in the next chapter, we're gonna talk about the approximately distributions of the sample proportion, which is that one. Yeah. And we're gonna do together about these questions, and then we're nearly finished.